Hello friends, welcome back. Let us continue with the problematic part. So this is the question they are asked in the 2016 and as it is asked for the 1 month. Now let us see what they're asking. The results of a consolidation test on a undisturbed sample at a depth of 10 meters below the ground level. So saturated unit weight is given, pre-consolidated pressure is given. The water table was then counted at the ground table, assuming unit weight of water. They are asking the over consolidation ratio. What is the over consolidation ratio? Effective stress in the past divided by effective stress in the present. So pre-consolidation means in the past it is given how much? 90. Now at what depth we are going to find? We are finding at a depth of 10 meters. So what about the present? That is nothing but a 10 into saturated unit weight is 16. As we need the effective minus unit weight of water 10. 6 into 10, that implies what is the answer? 1.5. Right? Do not consider it as a 10 into 16, you will end up with the wrong answer. Move on to the next. So this is the question they are asked in the year 2015, asked for the 2 marks. Now let us read. A 20-meter thick clay layer is sandwiched between a silty sand layer and gravelly sand layer. The layer experiences 30 mm settlement in 2 years. Now what we need? What is the time factor and degree of consolidation? Right? So let us find out the time factor. So here time factor is what is the question? If consolidation is this much, what is the deposit will experience a total settlement in how many years? Right? So in 50 years we have to find out 50 years settlement is how much. So it is given that 30 mm settlement in 2 years. Now what they're asking, if you want to have the 50 mm settlement, then that should occur in how many years? Now for that, what is the relation? Use the time factor. Time factor will be equal to CV into T by D square. Now, coefficient of consolidation is given, but did anything mentioned about the D square? No, right? That is a value that will occur from this layer. Or see here, 20 mm thick clay layer is sandwiched between silty sand layer and the gravelly sand layer. So what do you think? It is a single drainage or double drainage? Gravelly sand means, and also on the other side it is a silty sand, and on the other side it is gravel. As it is a gravel sand, it is more permeable. We can consider it as a single drainage. So if you substitute in this equation, what is the time factor? 0.003. Here it is a centimeter square per second into substitute your time in seconds. So how much time is given? That is what we have to find out. So let us keep it as a T divided by what is the thickness? 20. As we're substituting in 20 centimeters, let us say convert into centimeter. 20 into 100 whole square. But again, the thing is, we don't know the T value. Then how can we proceed? So first of all, we have to find out what is the total settlement of the clay layer. So let us first find out what is the total settlement. So how can I find out? By using this relation TV, that will be equal to CV is given as how much? 0.003 centimeter square per second. So remember, into whatever the time required, 2 years. So let us convert into seconds. How many days? 365 days. How many hours? 24. How many minutes? 60. How many seconds? 60. Divided by 20 meters. Convert this into centimeters. So how much it will be? 20 into 100. That means 2000 whole square. Right? So if you solve this, how much will you get it? Hold on a second. Let me do this. 2 into 365 into 60 into divided by 2000 square into 0.03. So if you're solving this, you are getting this as around 0.473. Now here, corresponding to this time factor. Okay, now you have to find out what is the forward degree of consolidation u. So what will happen once you are getting the degree of consolidation? That is what nothing but a settlement divided by final settlement into 100. Now settlement is given, so from this what you will can get, you can get the final settlement. So this is what the required magnitude you have to find out. In the second case, what you have to find, you have to find out how much time required to get the 50 mm settlement. For this, what you should know, you should know the time factor. If you know the time factor, you should know the degree of consolidation. From this, as you're already finding the safe settlement, 50 divided by SF, then you will get this value in some percentage. Then again, what you will do, depending upon the U value, you just, if it is less than 60%, use this magnitude. If it is greater than, use this value. And then you will get the time factor value. After getting the time factor, substitute that equation in this. Then you will get the time value. And take the proper units. And at the end, you will get this time required is 4.43 years. Just try this out. Okay. Just a simple calculation. In this part, you should understand that this part you can only be done only if you know the degree of consolidation. That will be only known if you know the total settlement. The total settlement will be found out by using this relation. Fine. Okay, these are the problems about the consolidation. In the next lecture, we'll see the problems on the shear strength. Thank you.